Unit 1 Chemistry, Chapter 6, Materials Made of Molecules. So you've probably heard the term molecule and maybe used it in quite a generic term. What we actually mean in chemistry when we talk about a molecule is a distinct subset of atoms that are covalently bonded together. So a covalent bond, we're not swapping electrons because a covalent bond is two nonmetals and both of them therefore want to gain electrons. So instead of that, they share. And by sharing them, what we have is electrons that circle both nuclei and are therefore going round and round both of them and get counted twice. Okay, so if we're talking about covalent molecules, we can either get simple ones where we've got two or more atoms, and that's where we get our distinct molecules. We can also get covalent lattices, and we'll look at them later. Okay. So think about chlorine, for instance. Now, a chlorine atom, just one of them, has got 7 electrons in its outer shell. Okay, 1, 2, 3, 4, 5, 6 are paired up, and these ones are not going to bond because they're very happy. But then we've got this last one, which is on its own and it wants a partner, so it's going to pair up with the free electron, unpaired electron, from another chlorine atom. Okay. These 2 electrons are called our bonding pair, and they are going to orbit around both of these chlorine atoms, which is why you get Cl2, because Cl2 is a stable molecule where you've got 8 electrons in the outer shell. The same with H2. Okay? This is a charge diagram showing the same thing as that. And these dark bits here, that's the region of space where you're most likely to find the electrons. Okay? You can also get a covalent bond between different elements. So hydrogen has only got 1, wants 2, so it's going to share 1 and get 1. Okay? Chlorine will do the same thing. This will make hydrogen chloride or hydrochloric acid. Again, we've got 3 non-bonding electrons and 1 bonding pair. We can do it where we get more than 2 atoms to make the molecule. So water is a classic example. So oxygen's got 6 in its outer shell. Hydrogen's got 1. So oxygen needs to gain 2 more electrons from somewhere. Each hydrogen, though, only wants to gain an extra 1. So, to make sure there are enough to share, we've got these 2 non-bonding pairs. Then here, we've got 1 of the oxygen electrons and one of the hydrogens. And here we've got the last one from oxygen with the other one from the hydrogen. Okay? So it's sharing 2 electrons, but with different hydrogens. Sometimes we can share more than 1 electron with the same atom. Okay, so 2 oxygens, for instance, each of them's got 6, so each of them needs 2 more. They don't need to do that with lots of different oxygens in a row. They can share, each of them, 2 and 2, as long as it's equal, as everyone's giving the same amount as they receive, everyone's happy. Okay, because that means that we're still ending up uncharged overall. So this one here we'd call a double covalent bond. And we've got 2 bonding pairs, so double. Nitrogen does the same thing, but here we've got 1, 2, 3 bonding pairs. So we'd call that a triple bond. And they can have a mixture of them as well. This is something called ethene. So we've got 2 carbons with a double bond holding them. And then each carbon has also got 2 hydrogens on it, because carbon needs to share all 4 of its outer shell electrons to get that full stable octet.